This is your yellow piece of paper. I just have mine in white. Yeah. Vitoya was just asking about how to use it, and he was kind of overwhelmed with it, so I want to show you guys what to do. All right. Question number 2. I will go through an answer because you guys have been asking about it because you need some help. All right, question number 2 in our thick packet. I'm just going to go through it. If you haven't given yourself a 5 out of 5, most people have been saying it's because they were kind of shaky on it, and that's why I'm going through a practice question. All right, so question 2. This one. Does that help? Yeah, I know I made some boo-boos, and there's like multiple question 2s. You want the one that looks like this one. It should be the second page. Yeah, I messed up. This is what happens. All right, so first one we always look at is IR spectra. 2 things whenever we're looking at IR spectra is to help navigate us. We look at the 1700 section. Now I'm putting this in orange pen because this is just me helping process. It's not actually part of the answer, but if you write it down, it's more evidence for me. The other thing I look for is the CH. So my CH over here. And I use those 2 things as my navigators. Are we good so far? All right. Now, the reason why I want those 2 things at navigators is the first thing is that the 1700, that is where I'm going to see the carbonyl peak. And what I'm basically asking is, do I see that big trough? And answer is yes. So I go, oh, that must be C double bond O. Right there. Are we good? All right, now, looking at our resource sheet here, I don't want you guys to get bogged down on like the really long list and using it as like a checklist to be like, ooh, do I see the alkanes? Do I see the haloalkanes? Do I see the alkenes? Do I see the alcohol? You don't need to do that. This is just a reference guide, so that way when you eyeball the IR spectra, you can double check if this one is correct. All right. So that's the first thing that I'm labeling. Second thing I'm looking for is there's my CH, and I'm looking to the left of it to see if there's anything there. Do I see anything that's characteristic of an OH or an NH2? None. So I'm going to write no OH and no NH. And we can write NH1, NH2 if you guys want to be more specific. It's really important to state what's there and what's not there because that is evidence for me. Especially at the achieve. So let's say you forgot to label this guy, but you do have this labeled, I can still give you points for that to pass. The other thing is if you're working up to the excellence level, I need you to rule out other options as part of the excellence level answer. So those are my 2 bits of information. Now I can go back to this guy and just confirm. So I personally like to look on this column here because it gives me the functional groups. Obviously, they have the carbonyl a couple of times because they're mindful that the carbonyl could be in a carboxylic acid, could be an amide, could be an aldehyde or a ketone. It does shift very slightly, but the main thing to look at is that with the carbonyls, they're all roughly around 1700. I wouldn't use that as an indicator per se of like this carbonyl is definitely in this type of molecule because these are so close together. What I would use instead is the other hinting information. So from this hinting information, I don't see OH and I don't see NH2 or NH1. So what that tells me then is that this is an aldehyde or ketone. So I'm just making that note, aldehyde or ketone. Are you okay with that so far? All right, and if I look over here, the aldehyde and ketones, you see they even have overlapping sections, so it wouldn't be a way that I would use to distinguish between the 2 of those. I just know it's roughly in that zone. But like even these guys, the carbonyl in a carboxylic acid is still in a very similar spot. So I wouldn't use it, like I said, as a distinguishing factor. It's just to give you a ballpark. All right, next thing, if you guys want to do, just to help you guys just get used to what you need to do for the achieved, is go through and count your peaks here. There are 1, 2, 3. This tells me 3 carbon environments. That's the other achieved criteria. Tomorrow's lesson, I'll teach you guys what the CMMR does. But for now, just the achieved. All right. So last one is my mass spec. And if I'm trying to figure out my base peak, I'm looking to see what the 100% is. I'm labeling that, and that's my base peak. This one is really nice because the molecular ion, in this case, is quite large and noticeable. So this one is my molecular ion. And if I did my counting, that's at 86, which is really important because we're going to need that to help figure out how many carbons I have. All right, are we okay so far? All right. If you do all that, you have now passed. That's it. Yeah, nice and easy. All right. I will move on to the merit stuff now. What else did I want to say? Oh, so just as a reminder, with the molecular ion, there are going to be 3 situations. First situation, molecular ion is very obvious. It is the rightmost peak, and it is the mass. Sorry, it's the mass of the molecule. So if it's really obvious, I won't label it. You will have to label it. If it is tiny, and I don't think you're going to be able to see it, I will give you one of 2 hints. The first hint will be I will just label it for you, which would be very, very nice. The second hint is I will give you the empirical formula. And the empirical formula means that the molecular formula must be some ratio of it. So times 2, times 3, times 4. Okay? So keep that in mind. And that you guys have been working on some problems to kind of see that. All right, so that's now something I know is that it's 86. And I want to play with this idea that I know I have a carbonyl. Now, my personal preference when I'm trying to figure out how many carbons I have is I assume the functional group, and I assume it's on carbon number 1. So that way I can then figure out how many carbons am I adding to it. So if I had a carbonyl on the end, carbon, it would be C double bond O. It would then be attached to something. Don't know how long that something is. And then I would have 1 hydrogen there. So that's the basic setup for the functional group that I've identified. Are we okay so far with that? Okay. So if I was to do the math here, carbon has the atomic number of 12. The oxygen is 16. Not atomic number, atomic mass. So if I add that together, we are currently at 28. And then we add the 1 hydrogen. So I'm at 29. So that is my starting mass that I'm thinking about. Okay. Here's a little hint on the resource sheet on the back side. I give you a list of common fragments if you haven't figured that out already. So actually this one here, the CHO, that's 29 because that one is the C double bond OH. So there's some shortcuts there if you want to. We'll use it more next week. But I just want to show you that some of them are there. All right, now I play the game of add 14 until I am at 85. So 1 away from the molecular ion. So 29 plus 14. That is going to be 43. Yep. Right. So the 14 I got. If we are assuming any inside carbons, so let's say I had a carbon chain like CH3, CH2, CH2, CH3, like that. This is my inside carbons, right? And my inside carbons are 14 because I know I have 12 for the carbon and then 2 for each of the hydrogen. So that's why we're playing the game of add 14. Yeah? Add 14 until we are 1 away because when we get to the end, we have an extra hydrogen. Yeah? Add 14 until 1 away because then you add the extra hydrogen. Cool. Okay. So I had 29, my first 14, that gets me to 43. If I add another 14, that gets me to 57. If I add another 14, that gets me to 71. Still not there. Add another 14, 85. So I'm finally there. Because now I'm 1 away, and then you'd add the 1 hydrogen at the end, 86. So what that tells me then is that I have 1, 2, 3, 4, 5 carbons in this chain. Okay. And from there, you can start trying to figure out the molecule. Cool. Feel better? Do you want me to do another one? I'm happy to do another one. Which one would you like me to do? Number 4? This one? Yes? Okay. All right. If you're happy, feel free to keep working. If you want to listen to me, you're more than welcome to. All right. First thing I'm looking for, do your 2 reference points. So 1700, that's 15, 16, 17 is right here. Would I say that this is a carbonyl? No, because we know that those carbonyls are like, they're like almost at 100%. So we're going to say no carbonyl. All right, next thing we look for our reference point is our CH. We look to the left of it. I see something here. What is that characteristic of? An H2. Should I write NH2? All right. Amine or amide? Amine. Because if it was an amide, we would have the carbonyl, right? The other thing to keep in mind is if we had an amide, we would see that NH2 trough go really deep as well. So that's why you guys got to look at a lot of them. All right, so I've figured out from that information there, that is an amide. If I want to look at my reference sheet, I can look for my amines, and I would see that with the NH, it's between 3,300 and 3,500. So I'm just looking to see, is that roughly in that same zone? And it is. So it's just a way to double check yourself. All right, looking at my CMMR, how many peaks do I see? 3, so 3 carbon environments. All right, and then looking at our mass spec, base peak, that's 30. And then I haven't labeled it because I think it's pretty obvious which one it is. It is, which one? This one, 59. All right. To be confident that you know that 59 is the right answer, remember that if you have a nitrogen present in the molecule, it has an odd number. And you should use that when you're justifying your write-up because it helps you kind of show. So like if you're looking for the excellence level criteria, stuff like that would help you get up to excellence, like using the spectra to back each other. So I'll actually write this in green because that would be excellence level evidence for me. So odd number confirming nitrogen. So I would suggest you write that down because it's a good way to show me excellence or get like excellence points. And again, I'll talk about that more next week. All right, we okay? All right, keep going. All right, so now again, we assume the functional group is on carbon number 1. So if I was to draw this, it would look like carbon. It'd be an NH2. I'd have a question mark because I don't know what else is attached to it. And then this carbon at the end would have the 2 hydrogens like that. So again, let's figure out the math. So I have carbon, which is 12. I have the nitrogen, which atomic mass is, I want to say 14. Yes, because oxygen 16. And then I have 1, 2, 3, 4 hydrogens. So that's 4 being added to it. Do you agree? So add that together. 4 plus 4 is 8, plus 2 is 10, carry the 1, 30. So this is 30 to start with. Now we just play the game, add 14. So if I do 14 there, that gets me to 44. If I add another 14, 58, which is 1 away. So that tells me we have 1, 2, 3. So there's 3 carbons in this chain. Yes. Because, do you want me to show you the other piece of paper to remind you why it's 14? You got it? Oh, you got it? Okay. It's because CH2 is 14. So carbon's 12, 2 hydrogens, you add 2, 14. Yeah. This one you keep adding 14 because that's the value. All right. We okay? Okay. Mama Michelle? Yep. Any other ones you guys want to see? Are you okay to keep working? No? You got 10 more minutes. Want me to do 5 as well? Do you have 5 done yet? How about you give 5 a go and I'll check it? Because you guys need to practice. Yeah? Okay.